Welcome to Grade 3 Science. I'm Keisha Richards, and together we will explore and learn more about science. You know why? Science is fun, science is cool, science is awesome, science is all around us. So get your books, get your pencils, and let's learn science today. Today we'll be working with the topic properties of states of matter. And the last lesson we focused on solids. Today you're going to look at the physical properties of liquids and gases, and you're going to compare the physical properties of liquids and gases and solids, all the states of matter. Good? What are physical properties? Remember, we did that in the last lesson, right? So physical properties, it's actually the characteristics of a substance that can be measured or observed. Examples would be taste, odor, temperature, texture, length, volume, etc. What are some examples of physical properties of solids that we did in the last lesson? Now, remember, solids, they're hard, they have fixed shape, they have fixed volume, and they also have a definite shape. They are also difficult to compress, right? So that is what we learned in the last lesson concerning solids. So what are some examples of liquids? Good. Water, milk, kerosene, juice, alcohol, all of those are examples of liquids. So we're going to look at the physical properties of liquids. So here we have colored water in a container. Can you describe the shape of this container? This container is actually a volumetric flask. What is its shape? It is actually a bulb shape at the bottom, flattened, with a long neck. Good? What is the shape of the liquid? Exactly. It actually takes the shape of this container, which is a bulb with a flat bottom and a long neck, right? Good. Now, the volume of this liquid, or the amount of liquid in this container, is actually 100 ml, 100 milliliters. What do you think will happen if I transfer this liquid into this container? What will happen to the amount of liquid? What will happen to its volume? Will they change? Will the shape and the volume change? Let's see. Now, what do you notice about this liquid in terms of transferring it to this container? Good. It can flow. It can flow. So this liquid flowed into this container. So another property of liquid here is that it can flow, or we can pour it. Good. Do we still have the same shape as in this first container? No. The shape has changed to suit the shape of this container. What is the shape of this container? We can simply say cylindrical. What about the volume or the amount of this liquid? Did it change? Let's see. Good. It is actually 100 ml like it was in this container. So what does that tell you about the shape and the volume of liquids? Good. The shape changes to suit the container, but the volume remains the same. So for liquids, we have learned so far that it can be poured. We also learned that it will take the shape of the container in which it is in. Also, the volume is fixed, or we say definite. It will not change. Good? So, those are three properties that we would have learned so far concerning liquids. Now let's focus on another property. So here I have a syringe. Good? So this syringe, here is the plunger, here is the barrel, and this is the tip or hub. So what I'm going to do is to fill this syringe by placing the tip with the plunger down in the liquid, and then I will slowly pull up to about 2/3 of the barrel. Good? So the volume of this syringe is 3 ml, and therefore I filled it to the 2 ml mark, which is 2/3. All right. So what we are going to do here is try to compress this liquid. So I'm going to cover the tip and I'm going to press on this plunger. So let's see what happens. I'm pressing as hard as I can. Good. It's very difficult. And it is still at the 2 ml mark. So what does that tell you about liquids? Yes, like solids, they are difficult to compress. Good? So we have learned about 4 properties of liquids. Number 1, it takes the shape of the container. The volume is fixed or definite, it doesn't change, as well as it can be poured from one container to another. It can be poured, or we can say it can flow. Good? So here is a table to summarize what we have learned so far concerning liquids. Good? All right. What about gases? Can you give me some examples of gases? Very good. Oxygen, carbon dioxide, nitrogen, or a mixture of gases which we call air, or the steam or water vapor that comes out of our pots when we cook. Those are all examples of gases. Good? So, for most gases, they are invisible. Right? So, in this container, we can safely say it's not empty, but it has gas in it, right? As you can hear, I'm squeezing some of it out. Good. So that tells us that air fills containers that seem to be empty. Good? So here we have two inflated objects. This is a balloon and this is a glove. Do you notice the difference? Yes, the shape is different. So what does that tell you about gases? Very good. Like liquids, they take the shape of the container in which they are. So this glove is like the shape of our hand, right? Or actually our palm. So the air actually fills this glove and takes the shape of the glove. Good? The balloon is more rounded and therefore the air takes the shape of this balloon. Good? If I try to reduce the size of this glove, what does that tell you? Right? It tells us that air or gases, they can contract or be compressed to fit any size container. Right? So if I'm going to release this, so it's actually expanded to fit the size of this glove. Another way we can investigate that is with the syringe. So with the plunger down, I'm actually going to pull the plunger up to about 3 ml, right? So I actually pull the air up into the barrel. So I'm going to do it like I did with the liquid. So I'm going to press as hard as I can with my index finger covering the hub or the tip. So I'm going to press as hard as I can. What do you notice? The plunger going down to about 0.5 ml. So the gas in this syringe would have been compressed from 3 ml to 0.5 ml. What do you notice now? The plunger was pushed right back up. So I'm going to compress the air again. And I'm going to release. And you notice the plunger was pushed right up again. Again, we're going to try it for the third time. Plunger comes right up. So what does that tell you about gases? That they contract to fit small containers or they expand to fit large containers or large spaces. All right, so what does that tell us about gases? Number one, like liquids, they take the shape of the container in which they're held. Number two, if I'm going to reduce this size, then the gas will be compressed or contracted to fit this size. So it tells us that the volume or the amount of air in a container is not fixed because it can expand or contract to suit its container or space. And lastly, it can be compressed. Good? So here we have summarized the results of our investigation concerning gases. Shape is not fixed. Volume is not fixed. They fill the size of their containers. Compressibility, it means they can be easily compressed. And like liquids as well, I must add, gases can flow, because if I'm going to press in one of these fingers here, the air in this finger will actually flow into the rest of the glove. Right? So air can flow. If I squeeze it, you'll see it will flow from one part to the next. Good? So, altogether, we learned that for liquids and gases, the volume is fixed for liquids, but not for gases. The shape, not fixed for gases and liquids. Ability to be compressed. Gases can be compressed, but not liquids. And ability to flow, both liquids and gases can flow. So those are the properties of liquids and gases investigated today. Now let's think about what we would have learned in the last lesson and this lesson. And let's see how we can compare and contrast the properties of matter, that is, solids, liquids, and gases. Good. What about the shape of solids? Very good. Solids have fixed shape. Like this container here, it's a solid and the shape is fixed, cannot change. But for gases and liquids, the shape is not fixed. They take the shape of their containers. Volume. The volume for solids, they're fixed. It doesn't matter where you put them, the volume or the space they take up is the same. But for liquids, also the volume is the same from one container to the other. But when it comes to gases, the volume is not fixed. It changes to suit the space available or the size of the container. In terms of ability to be compressed, liquids and solids are difficult to compress, but for gases, they're easily compressed. In terms of ability to flow from one container to another or one point to another, liquids and gases can flow, but solids cannot flow because the shape is actually fixed. Good? So that summarizes what we would have learned so far in terms of physical properties of states of matter. Name one physical property that is the same for a liquid and a gas. Name one physical property that is the same for a liquid and a gas. Or if you want to do both, name one physical property that is different between a solid and a gas. Name one physical property that is different between a solid and a gas. Good? So that's it for today. Remember, science is all around us. Goodbye, children. See you next time.